got to word problems. And, okay, we stopped there. All right, so let's go to the next word problem. This is the motion formula. D equals RT. If you think about it, D for distance, R for rate of speed, T for time that has passed. The distance traveled by an object moving at a rate R in what time T is given. Then we have a word problem right here, and then we have a picture. Then we have a picture to help us understand what's going on. Okay, let's go read the word problem. Airplane speed. Do I need that? No. Delta Airlines fleet includes B737 800s. Do I need that? They're telling you the type of plane there. Is that necessary? No. They're just throwing numbers in there to try to throw you off. Delta's fleet has some planes, right? So you got Delta Airlines. Each plane has a cruising speed of 517 miles per hour, and Saab, which is a different airline, Saab 340Bs, each with a cruising speed of 290 miles per hour. Not a different airline, a different plane. So if you look at this, the first thing that I'm going to tell you that bothers me is when I'm reading something and I have trouble pronouncing it, or if I don't understand what I'm talking about, it bothers me, and it makes it harder for me to understand the problem. Are y'all the same way? Okay, so a technique that I use when I'm working word problems like that is I rename things with letters. So instead of the Delta Airlines fleet of B737s and the Saab 340Bs, I have no clue what I'm talking about. I'm just going to call this A, and I'm going to call this, what do you think, B. So now I know Delta's got plane A, and they've got plane B, right? Now I can understand it a little bit better. I know plane A goes what? Cruising speed of 517 miles per hour. And then plane B goes cruising speed of 290. Now doesn't that sound a lot less intimidating? Just by renaming it with a big old capital letter. Okay. Let's keep reading. We don't care about the source, right? Suppose that, now everywhere in the problem you got to rename it. So suppose that plane B takes off and travels at its cruising speed. 1 hour later, now which one was this? This was A. 1 hour later, plane A takes off and follows the same route, traveling at its cruising speed. The question is, how long will it take plane A to overtake, which means to pass, right, plane B? How long will it take it to pass plane B? So not only does it have to catch up to it, but then they want to know at what time will it catch up, because then any time after that, it's going to now be passing it, right? Okay, let's talk about, let's take some notes. So you read the problem, you rename what you need to, you mark out what you need to, and then you go back and you read it again and you take notes. Delta's plane A goes how fast? Cruising speed. So I'm writing plane A goes 517 miles per hour. Delta's plane B goes 290 miles per hour, right? Using the motion formula at the top of your box of notes, D equals RT, right? Okay, D is distance. We need to know the distance, so that means we don't know D. R is the rate at which the object is moving. Do we know it? Yes, we know it in miles per hour. And T is the amount of time that has passed. We don't know the time that's passed. That's what they're asking. At what point will the one plane overtake the other plane, right? So these little cliff notes here can now, I have another arrow, which basically is me saying, okay, my thought process is A goes this fast, which means the formula for motion, the motion formula of plane A would be D equals 517 times T. Now, plane B, as we're reading it, it says, suppose plane B takes off and travels at its cruising speed, and then an hour later, plane A takes off. So which plane left first? B left first. And how much more time has B been in the air than plane A? An hour. So when I come over here to write the formula for plane B, B was already in the air. It's already going 290 miles an hour, right? Instead of it just being 290 times T, I need to adjust T to indicate that it's already been in the air for an hour. So when I write this, what do you think I'm going to tweak it with? I'm just going to add a 1. 6. You do it minutes. Since the speed is in hours, and if you throw minutes in there, you would need to convert the speed to minutes to be consistent. Does that make sense? What we can do, since speed is in hours, we'll just put the hour that it was up in the air, and then at the very end, we will have to take into account. Does it say minutes? No, it just says how long. So at the very end, we can answer in hours. And then if it's not a perfect hour, we can find how many minutes additional is remaining. So I'm going to write T plus 1. Notice I did put it in parentheses because it is the time, but there's an additional hour on it. Now I'm going to change colors and draw an arrow. And I'm pointing to the 1, and I'm going to put 1 hour head start. So that's where the 1 came from. So you have a motion formula for plane A going 517 miles an hour. You have a motion formula for plane B going 290 miles an hour, having been in the air an additional hour, right? And the question is, how long is it going to take for A to pass B? If A is going to pass B, first it has to be, what? In line with B, which is what math operation starts with an E. Equal. So if I want to know when is it going to pass it, I can find when they're equal, and then it's the given hour, given time after that. What do you notice both of these are equal to? D. So don't complicate it just because they both are equal to D. It's substitution. This value of D is 517. That value of D is this mess. So I can plug one, I can just set them equal since they're both equal to D. It's the transitive property. If A is equal to B and B is equal to C, then A is equal to C. Does that make sense? So if this mess is equal to D, and this mess is equal to D, then the two messes have to be equal to each other. All right, so let's take some notes. Set them equal since both equal D. This is why we're doing this. Okay, so 517 T equals 90t plus 1. Solve that. You are going to distribute, and then you're going to have to subtract and divide. Did you get 1.28? Yes. Okay, now we have a problem. What's the problem? It's a decimal. If I said, how long is it going to take for the plane to pass the other plane? And you told me 1.28 hours. Doesn't make sense, does it? Now, if it said 1.5 hours, it'd be nice, but life's not that simple, right? So we have to translate this, okay? Level it up. This means 1 hour, and then you're going to have to find the 0.28. Think of it as 28% of an hour. So you need to know what 28% of an hour is, which means you need to know how many minutes are in an hour. There are 60. So I'm going to write right here, it's 1 hour and 28% of 60 minutes. This is how we're getting it. So go to your calculator and do 60 times 0.28. And you get 16, right? So 1 hour and 16 minutes. Whatever the decimal is just a percentage of the number of minutes in an hour, and then you just multiply it at the end to get the minutes. If it had been 0.5, if you think about it, you would do 0.5 of 60, that's 30 minutes, which is why 1.5 hours you already know is an hour and a half. Before you turn the page, because this is going to come up in number 7 of the homework, so make a note. MML, number 7. Let's talk for a second. This problem worked out the way it did because plane B took off an hour ahead, and then we were trying to figure out, when do they equal, so plane A has to play catch up, right? So I made notes for about last year. What if it said the word earlier? If it says earlier instead of 1 hour later. So if it was earlier, you would need to adjust it. If I said plane B left an hour earlier than plane A, you would have to go in and subtract the hour off. Does that make sense? So you have to think about, you might want to make a note on your paper, like earlier, quote earlier, you have to think would mean subtraction, right? In this case, what did they use? Later, which meant we were going to add time to it because it had already been in the air. I'm trying to remember the exact trick in my math lab. There is a conversion, that's what it was. There's a conversion of the information they give you is in hours, and then they ask the question in minutes. So, watch out. Make sure your time is of the same unit. So, maybe make a note, check T for same units. And what I mean by that is everything in hours? Is everything in minutes? Because that's what it needs to be consistent. That is going to happen on number 7. And I will be happy to tomorrow morning, or at the end, we won't have time. So tomorrow morning I'll be happy to start the class with number 7 if you want me to. But I would like you to try it first. Okay, I don't want to take the thought process away from you. I want you to try it first. If you can't get it, I'll do it first thing tomorrow. Okay? Alright, let's do another one. This time it's interest, but it's simple interest. It's not compound interest. It is simple, which means it's simple. You just plug it in. There's nothing fancy. I equals PRT. This is the formula. That is an I, by the way. It doesn't really look like it. I equals PRT. P always stands for the starting amount that you invest or that you put in the bank or where it starts. Rate, R, make a note, always needs to be in decimal form. It always needs to be, so the percentage, you need to convert it to decimal form before you plug it in. And then T in years. Okay, let's read this one. Student loans. Woo, this is very pertinent to now. By the way, if you're trying to go to college and there's just, it's an enormous amount of money, go to the registrar's office, to the financial aid department, and ask about scholarships. There is money out there. There is a ton of money out there. It's just people don't apply or they don't ask, they don't inquire. There's also assistantships, undergrad assistantship, a graduate assistantship. That's how I paid for my master's degree, was I got a graduate assistantship. It was absolutely brutal for 1 year. It was 1 year of the most intense work I've ever done, of teaching all day, driving to Atlanta 2 days a week to sit in class for an hour and 15 minutes, driving home, going back to work. Then I transferred to UTC, got the assistantship. I was working 5 days a week, going to class 2 days a week, or 4, depending on if they didn't line up. And then I was working in the math lab. Not the math. Don't do the other. I was working in the math lab where it counts. Oh, so many jokes. But anyways, it paid for it. It paid for my degree. It did it absolutely. Yes. Oh my gosh, I was so tired and exhausted. But for 1 year, I was like, I can do it because it's a lot of money that I don't have to pay. So look into money. Don't be one of these people that is sitting on student loans 20 years after you graduated. You know what I mean? There's money. You just got to find it. Okay. DeMarion's 2 student loans total $28,000. One loan is at a 5% simple interest and the other is at a 3% simple interest. After a year, he owes $1,000 in interest. What is the amount of each loan? Okay, so this is one of those problems I like because there's not a lot of writing, and honestly, there's really no fluff, right? If you read the sentence, or if you read the problem, there's nothing in here that we can cross out because everything is straightforward. But we do need to take some notes. How many loans does he have? Okay, and we need to assign variables to him. I'm just going to call X the first loan. Now we need to write some info. The first loan is at what percent? 5%. And I'm going to go ahead and put my 5 as a decimal so I don't forget to. Remember, if you forget, if you panic and run like the pig in Chicken Little, if you panic and run with decimals, just remember that there's only 2 directions to change the decimal, right? Either right or left. Well, if you go right with it, now it's 500, which should not make sense. So use a little, like a checkpoint, you know, if you're panicking as to which way to change the decimal. So that's 0.05. I'm going to let Y be the second loan. 3%, and that's 0.03. I'm going to go back to my problem and see if they gave me the time. It said right here T is 1 year. We have two variables, which means we will have two equations, okay? I want you to think of the words quantity versus quality. Have y'all ever heard of quantity versus quality? To put it in the standpoint of teaching, it's a discussion among every teacher at the beginning of the year. Am I going to try to hit every standard that I'm supposed to hit? That would be quantity. Or am I going to try to hit 80% of the standards that are important, that carry on to the next classes in a rich, meaningful way? That would be quality. So in this problem, we have a quantity, which is our total. Then we have a quality, which is the value of each one. Okay? So first, the quantity should be the easiest every time. That's the total. How much does he have in loans total? Total. $28,000. That's between the two loans, right? So the X loan plus the Y loan sums to $28,000. Does that make sense how I got that? Think of these as just blocks of numbers. Like he has this amount of money he took out, he has this amount, it adds to 28,000. Okay, the next one is going to come from after a year, he owes this much in interest. This is telling you the quality of what each loan's interest rate has valued up to be, and it values at $1,040. So I'm going to write the equation, and then I'm going to explain where it came from. And this is the same way every time. Okay? So the $1,040 is the total amount of money in interest that has accrued. And that came from a 5% rate on loan X, 5% rate on loan X, and means add a 3% rate on loan Y. Look at the difference between the two equations. Plain X, plain Y stood for the two loans. If I just add them up, I get the total amount, $28,000. Look at the second equation. This is usually the harder one for people to come up with. Now you're taking into account loan X is at a rate of 5%. Loan Y is at a rate of 3%. The rate of interest is where the interest accrued comes from, right? So that's why these three numbers need to go in their own equation, because they're not the quantity of the loan, they're the value of the interest rate of the loan. Now it's a basic system of equations that you need to solve. You can solve it any way that you want. You can do elimination here. I chose substitution because these nice variables here, I just got one by itself and then I plugged it in. Right? Alright, so you try that. Try substitution. I solved for X from this one. I took this one and solved for X and then I plugged it in. So you try to finish it by substitution. You're getting the first equation by itself with one letter. I went for X equals. That means the Y needs to move by what? subtraction. I'm going to change colors. So I drew an arrow and I said to myself, so this is 28,000 minus y. So if x is 28,000 minus y, right here, where x is where you can plug it in. And now you have an equation with just y that you can solve. So distribute line like terms on the y's. And then divide. Does anyone have any questions on how I did the algebra? I used substitution. I took the first equation. I just got one of the variables by itself, and then I plugged that in. Then I cleaned it up by distributing here, then combining these like terms, then subtracting 1,400 over, and then dividing by negative 0.02. So this was y. Y was which interest rate? 3%. So 3% interest. Actually, we could just write the sum. It was $18,000 at 3%. How do I get the other? Subtract. Total is 28,000. So the 5% interest is 10,000. There's one thing we need to write that was not an issue here, and I don't think it is an issue, but at all. But I'm going to show it to you because I want you to know where it comes from. So in the formula for simple interest, it's P times R times T, right? If you look right here, the interest that we accrued on this one, we didn't take into account the time that passed, because what was the time? 1 year. So was that going to change anything? No. So I want you either with a pen or change the pressure of your pencil so it stands out. Do something to make it stand out. So had that been like 2 years, 3 years, or whatever, there would be right here the amount of time that has passed. You would multiply it by each of the interest rates and the amount of loan that was taken out. And I'm going to draw an arrow and I'm going to write YR for that is representative of the year that is passed. It's not an issue in this case because in a year's time, when you multiply by the 1, nothing happens. So they took out an $18,000 loan at 3% and a $10,000 loan at 5%. And after a year, he owes $1,040 on top of the $28,000 that he borrowed. Does that make sense? Word problems, I think, bog everyone down. They're probably depressing in some cases. Let's go to the next one. This one looks ridiculous. We've got solar panels. In December 2009, a solar energy farm was completed at the Denver International Airport. More than 9,200 rectangular solar panels were installed. Here's our source. A solar panel or photovoltaic panel converts sunlight into electricity. The length of a panel is 13.6 inches, less than twice the width, and the perimeter is 207.4. Find the length of the width. Good gracious. Go through and mark out what is not necessary. And I'm actually going to use a white pen here because I want you to just see how much of this was not necessary. Do we care when? Did they ask anything about when? No, so we don't care when. Do we care that a solar energy farm was completed at the Denver International Airport? No, I mean, that gives you a context of what you're visualizing, but does it matter? Nope. More than 9,200 rectangular solar panels were installed. Here's our source. We definitely don't care about the source. Do we care about how many panels were installed? Do you? Well, let's look at it. So you might think at first it's necessary. Let's keep reading. So I haven't X'd it out. A solar panel or a photovoltaic, do we care about that part? No. They're telling you the more scientific word for it, I guess. A solar panel converts light into electricity. Do I care about this? No. Isn't this fun? It's just going away. Now look at it. The length of a panel is, then they give us a relationship, twice the width, and the perimeter is 207. The length of a panel. Find the length and the width. Do I care how many there are? Nope. Does not matter how many there are. They are asking me to specifically focus on one. They're telling me the relationship between the sides, and they're asking me to find the length of it. So that entire word problem that started out like that is actually that. Okay? What would help here? What do you think? Draw a picture. What shape do we have? We have a rectangle. We're not going to draw a square because we don't know that they're actually square. We're going to draw a rectangle. Here we go. Sorry. We have a rectangle, right? What do you know about the sides of a rectangle? There's two sides shorter than the others. Usually we call those the width, and we call the longer ones the length. What else do you know? Something you know, but you just haven't told, like, I need to mark it. Before you get to the numbers, like, What do you know about the sides of a rectangle? I'm looking for what's equal. Look at my row. There's the long sides are equal, the lengths, and the widths are equal. So I'm going to make marks to show what you already know about rectangles, because this is going to help you. Now we have to read this sentence. The directions say find the length and width. I'm using cursive L because otherwise my lowercase l looks like a 1. Find the length and the width. If I have two variables, I should be able to get two equations. So read the question, or read the sentence. The length of a panel is 13.6 inches less than twice the width, and the perimeter is 207.4. There's your two equations. Now let's put it in let's take notes. The perimeter, I'm going to do a capital P for perimeter, is 207.4 inches. What is perimeter? It's the distance going around the shape, right? What shape do we have? Rectangle. And what are the, how many sides are there? 4. And you've already said that there are 2 equal lengths and 2 equal widths. So the formula for perimeter of a rectangle, if you recall this, I'm going to write recall. P equals 2L plus 2W. The 2's come from the fact that the lengths are congruent and the widths are congruent. There's 2 of them, right? So the perimeter is 207, and we're calling that the formula for perimeter is 2L plus 2W. So there's an equation right there. I'm going to replace the 207.4 in place of the perimeter P right here in this formula. Okay? So there's equation 1. I'm going to mark it. Equation 1. I have 207.4 equals 2L plus 2W. Now I'm going to change colors to show I'm trying to get the other equation. Go back to it. The length of a panel is 13.6 inches less than twice the width. The length of a panel. The length of a panel is and here's where you have to be careful, and it's because of this right here. Nope. Less than means we're subtracting, right? Okay, does order matter when you're subtracting? Yes. It looks like 13.6 minus 2W. This is twice the width. Looks like 13.6 minus 2W. But because it says less than, that means you reverse the order that it's written. Okay? That's every time you have less than. It's always a reverse of the order that it's written. Because if you think about it, it's saying that you have 2W minus 13.6. Because they're telling you it's 13.6 less than the 2W. So the 2W is up here, and then it's 13.6 less than it. So that's the order of subtracting. 2W minus 13.6. If you subtract in the other order and you go through this process, you should come to some negative numbers, which is your red flag. Ooh, I was supposed to switch that. So if I was to highlight or like say, you know, watch out on this problem anywhere, it would be the less than part. Okay, well, there's our second equation right there. I'm not even going to rewrite it over here. What method do you think I'm going to use to solve? Huh? Yeah. Look, L's by itself. This mess that is equal to L can go right there. And then I can solve it for W. You have a perimeter formula. Now you have an equation to represent the relationship between the length and the width, and L's by itself. So this is going to substitute in here.
So L isn't 13.6.
No. The length of a panel
That's not
is
period. That's just
13.6 less than 2W. So they're saying the length of the panel is 2W, shave off 13.6 inches. All right, so we have 2O. Whoops. Did you solve it and get 39.1? Did you get that?
yeah.
So if the width is 39.1, you would plug that in right here to get the length. All right, one more word problem. This will be your favorite. You could actually go ahead and look at it and probably solve it. It is similar to the cell phone carrier problem from the homework the other night. Okay, Metro Taxi charges a $2.50 pickup fee and $2 per mile traveled. Grayson's cab fare from the airport to his hotel was $32. How many miles did he travel? How many variables are they asking us to solve for? Just one. What letter do you think I'm going to use? M. If we have one variable, then we should be able to do this with one equation. This is just like your cell phone problem. There is a flat rate and then there's a per mile rate. And that's what goes in the equation. And you know how much he had to pay at the end, right? So I'm going to let M be number of miles. What's the flat fee? So 250, and I'm writing underneath it so y'all know where it came from. That's the flat fee. And then what's the rate? 2 per mile. This is the rate. And how much did he pay? Don't you love ones like this? So there it is in the pretty dollars. Here it is, it's just plain numbers. You got 2.5 plus 2m equals 32.5. I dropped off the dollars and the zeros that weren't necessary. So these are not like terms. You would subtract the 2.5, then divide. And you would say that he traveled 15 miles in a cab. More of those, right? All right, next slide. The purpose of this slide is to show you there are 4 vocab words for the same thing, and we've already discussed this before. If we are talking about the zeros of a function, we're talking about where the graph crosses on the x-axis. That's what we mean by the zeros. There are 4 more words to represent zeros. Well, 3 more words. You have the word zeros itself. You have x-intercepts. You have solutions. Then you have the one some people struggle to remember, roots. The way I remember roots is I think of where do the roots of a tree start? Right when it hits the ground, right? So I think of the x-axis as the ground, and this is the root. When you are dealing with functions, linear functions in particular, there is exactly 1 zero. Because if you think about it, it's just a line, and it's going to, so it doesn't curve or anything, so it's going to cross the x-axis just the 1 time. So I'm going to like shoot back around and cross it again. That would be a quadratic. Go to the next slide. Find the zeros of f of x, or the zero of f of x equals 5x minus 9. If we're finding the zero, this is where you have to know the vocab or the directions, like know what it's asking. If it says find the zero of a function, it means solve for x. That's what it means. Now, we do have 2 variables here. This is an understood what? That's an understood y. So if I'm solving for x, then that means I have to have something in for y, otherwise you can't do it. Remember, on the x-axis, if this is the ground, right, and the graph is crossing the x-axis, that's zeros, the roots, the x-intercepts, the solutions. What is the y value of every single point on the x-axis? 0. The y value of every point on the x-axis is 0. So, make a note. This means solve for x when y equals 0. We're going to do this 2 ways. Algebraic, then graphing. So algebraically, I'm just going to copy the equation. F of x stands for what again? Y. And we are going to let y be 0. So we have 0 equals 5x minus 9. Add 9. Divided by 5. This is ugly. Leave it alone. graph it, you would have to enter the equation, I'm abbreviating the equation, in y equals hold on. Enter the equation in y equals. Clear this stuff out. All right, the equation. Now you only enter the right side. It's already f of x. You know, it's already the y. All right, 5x minus 9. Zoom 6. We want to know the 0. Second calc. Notice the second option is 0. It's going to ask you those same 3 questions. Give me a left bound and a right bound. You've got to visualize like vertical lines, you know, the vertical spacing. No, I need a different color. Here's the 0 right here. Yes? Okay, so imagine a vertical line dropping right where it's crossing. Now you can see the left and the right. They want you to select enter while the cursor is to the left of the 0, which in this case it already is, left bound. Then they want you, oh, I'm on the thing, hold on. Then they want you to enter when it's on the right of the 0. When I touch this, I think the green's going to disappear. Oh, it did. Okay, good. So now they want you to put the cursor to the right of the 0. So if you visualize that vertical line, it can help you compartmentalize your left and your right on that graph. You will notice these little brackets pop up where you're telling the calculator, hey, narrow your focus right here, bud. And then they want you to put it right on the 0. And you get 1.8, which is exactly what 9 divided by 5 is. Now, let's write it down. So, enter in y equals, then you're going to zoom 6, which is standard. Then it's second calc. And you're selecting the one that says 0. And it's going to ask you your 3 questions. Left, right, guess. And you just press enter. And we came to 1.8, which is the same thing. Yes?
How do you simplify x plus x times a number? So it's usually an equation.
I'll have to come over there and look at it. Right here. I copied it because I knew this was going to be an issue. This is 7. This is the one I said, heads up, watch out. This is like the airplane one, but in terms of trucks getting on the highway. They tell you the speed in miles per hour, but then right here they say a car enters the highway 14 minutes later instead of an hour later. So you have to be careful here. Try it first. Try it on your own.